Hi there guys, today we're going to look at how to solve algebraic fractions. We're going to strip it all the way back to the beginning and then take it up to the very highest level. Now, before we do that, you also need to be really happy with solving quadratics, because what's going to eventually happen on the final stage, we're going to end up with a quadratic and then we have to be able to solve it. So let's just make sure that we are in a position where we are happy. So this one on the left here, question number 1, we have a bracket is being multiplied by another bracket and that equals 0. So when we have a multiplication that equals 0, you need to understand that if this one was 0 and that one wasn't, for example, 0 times whatever this would be 0. If this one wasn't 0 but this one was, so it would be 0 times this, that would also equal 0. So what we've got to do to make any multiplication equal 0, we've got to either make this bracket equal 0, so 2x plus 1 would equal 0, or we make x minus 3 equal to 0. If we do that, this multiplication will be 0. So if we rearrange this and solve, we would get x is minus a half and x is 3. So they are the two values of x that this multiplication could make 0. It's solved. Now, question 2, we've given it to you as a quadratic. So this is, well, subtraction in this case, but it could also be plus. Now, to find out which numbers go in here, that would be pretty difficult. But if we turn a quadratic into a multiplication problem from plus or minus, then it's easy. Right, we're back to here. So what we have to always do to solve a quadratic, well, it's not always, preferably we're going to factorize, but sometimes we can't factorize and we've got two other options there. So if we factorize this, we get x minus 7, x plus 4 is equal to 0. So now we've turned it into a multiplication problem, dead easy. This one, this left hand bracket, well, if that equals 0, x would have to be 7, and 0 times whatever this is would be 0. For example, if x is 7, you'd have 0 times 11. That is 0. It works. I could also make this bracket, the second bracket, equal to 0, and in that instance x would be minus 4. So that would be 0 times minus 11, and that's 0, so that works too. Okay, so if you get a quadratic, try and factorize. Most of the time you will be able to factorize, and you can easily solve it. If you can't factorize, we've always got completing the square or the quadratic formula, but 9 times out of 10 you're going to be able to factorize your answers. Maybe not in this video because I've made up all my questions, so we'll see how we go. Okay, let's start off easy. Way back when you first started doing equations, this is an algebraic equation, just the really easy ones. Let's call this stage 1. They vary slightly, so here we can see there's a shorter division line than there is here, but x's are all on one side, so it's really just a two-step equation. You get x's on one side, numbers on the other, but you've just got to do it in the right order. So what is the last thing happening to this x? Well, it's being times by 3, then divided by 4, and then take away 1. So if we add 1 to both sides, that's not the only way you can do it, but it's the safest way. We get this. This is an equivalent stage of working. Now, if we multiply by 4 to both sides, we'll end up with 3x is equal to 24. And I did that because, like I said before, what is the last thing happening to x? It's being times by 3 and then divided by 4. You could argue it's being divided by 4 and then times by 3 because of BIDMAS or PEMDAS, whichever way you look at it. Oh, that's not helpful. So it doesn't really matter which way you do this, you're going to get 8 as the answer. So for example, if I divide by 3 first, I'd had 2, and then I had to times by 4, I also get 8. Times by 4 at the start is possible, but most people forget to times this by 4 and then get it wrong. Okay, I am actually going to get rid of the denominator first here, because it is the last thing happening to the x. So it's been times by 3, then take away 2, then divided by 4, so let's undo it in that order. So if we times by 4 to both sides, it goes from the left and we get 16 on the right. If we add 2 to both sides, we're going to get 18, and we're just solving a simple equation there, so I'm not going to say anything more. Okay, stage 2. Stage 2 is just a fancy two-step. But whenever we see a fraction, we kind of want to get rid of it. That's our objective. Well, how are we going to get rid of the fraction on the right-hand side? Well, we just times by 5, yeah? But because it's an equation, what I do to one side, I must do to the other. So on the left, they're going to cancel. So what I would advise is you don't just tidy this up. You get rid of this one at the same time. So I'm going to just change colour for this. I'm going to go orange. So if I want to get rid of this divide by 4, I'm going to times by 4, and obviously that will cancel them out. But I have to do it to this side. So now what I've got in front of me is 4 lots of this. So I'm going to put that in a bracket because there's 2 terms. And we've got 5 lots of this. So we end up with 8x plus 4 is equal to 15x minus 10. So now we have a simple equation, but x's are on both sides, so we need to get them on 1. And let's collect them on the right because this has the most. So if we subtract 8x from both sides, we're going to have 7x. And because we've committed the x's to this side, we have to remove this number by adding 10 to both sides. Divide by 7, and we get x to be 2. And obviously, with any sort of equation, you can just sub your answer in, and if the left-hand side is equal to the right-hand side, you know it's right. So for example, if I put 2 in here, I get 1. So 2 times 2 is 4, plus 1 is 5, divided by 5 is 1. So this side should be 1 as well. So 3 times 2 is 6, take away 4 is 4, divided by 4 is 1. So I know I've got it right. So this example, I've flipped it, and it definitely makes it harder. But we're going to go for that same principle, remove the fraction. So how do I remove the divide by 2x plus 1? Exactly the same as before, we just times by 2x plus 1. I'm going to put it in brackets. Let's put all of these 2-term denominators in brackets. That's going to go. So if I do the same to here, because it's an equation. Okay, let's get rid of this fraction as well. So we're going to times by x minus 3. They're going to go. So we have to times by x minus 3. I just want to put some brackets around that one. Okay, so the fractions have gone, and all we have now is exactly the same as before, but in reverse order. So we've got 3 lots of x minus 3, so that's going to give me 3x minus 9, and we've got 2 lots of 2x plus 1, so it's going to give me 4x plus 2. So x is on one side, let's collect them on here again, get rid of this plus 2, and we get minus 11. You can sub that in to make sure it works. Let's move on to stage 3. So stage 3 is an extension of what you hopefully have been doing if you're watching this video. You hopefully have added, subtracted, times, divided, algebraic fractions, and now we're going to put them into this sort of environment. But it's really important to understand stage 1 and 2 perfectly, otherwise this can get a bit cumbersome. Okay, so we've got an add. We've got 2 fractions, so the natural thing to do is add them, and we're going to make them the same denominator, and the lowest common multiple for these would be 6. So this whole thing needs to be times by 2, so I'll end up with 4x plus 2. That's an equivalent fraction. And this side, well, it's not a side, it's the same side, so but this fraction needs to be multiplied by 3. So we have 3x minus 6 over 6, and again, these are equivalent. Let's pop the equal 1. Don't ever lose your equation. And now let's just combine them. So we have 7x minus 4 all over 6 is equal to 1. And you can see we're back to stage 1, and that's why it's really important to understand it. So I'm going to times by 6 first to get rid of the fraction. Well, and it's the last thing happening to the x. Now the last thing is the subtraction of 4, so I'm going to add 4. And we divide by 7. It's a non-friendly answer, but there it is. Let's have a look at another one. Subtraction. Always have to be careful with subtraction. 2 fractions being subtracted, same approach. Common denominator. And 12 is the lowest. Could have gone 24, 120, but why would you? That's just weird. So let's times this one on the left by 3. Now I have an equivalent fraction. Pop your minus in. Let's times this one by 4. And let's not lose our equation. Now let's subtract them. So we have all over 12. we've got 9x minus 8x. So, oh, silly boy, that's 1x. And we have, be careful here, minus 3 minus minus 4. Okay, so minus 3 plus 4 is 1. And again, we're back to the start. So, oops. So, x plus 1 is going to equal to 24 when we times by 12. So, x must be 23. And once again, just sub it in, the here and here, and you'll find it should equal 2. Okay, final stage. Always harder when x is on the bottom. So we have to add the fractions and we have to find a common denominator. Now, the only really way of doing this is multiplying them together. So two big fraction lines, and what we're trying to do is make them this. I'm going to multiply my two denominators together and I'm going to get this. So same thought process. Okay, so this one I've times by x minus 1, so now I have 4 lots of x minus 1. Plus, in the middle, this fraction has been times by x plus 1, so I have to times this by x plus 1. You can see if I cancel those two brackets off, I get back there, so I know it's an equivalent fraction. And the same thing here, if I cancel these two off, I get back, it's equivalent. I've not made it any bigger. The left hand side isn't bigger, so I don't need to do anything to the right hand side, because it's just a rewrite. Okay, so let's do this. So I'm going to try x plus 1, x minus 1. I thought about expanding it, because you wouldn't normally, but for these you do every time need to expand it. Okay, so let's see if we can skip a step here. So we've got 4x, add 2x, 6x. We've got minus 4, add 2, minus 2. So feel free to skip that step as well. This is dots, so this is going to be x squared minus 1. So now I'm basically at a harder version of stage 1. So 6x minus 2, I need to get rid of this fraction, so I'm going to multiply by it. And that denominator there is this, if you expand it, it's dots. Difference 2 squares. And when we times that by 1, we just get x squared minus 1. So now I've got a quadratic. Oh, sorry about that. So when you have a quadratic, it's not x's on one side, numbers on the other, it's everything on one side. And just make sure the x squared is positive. So if I pop everything on this side, that's what I get. Now that doesn't factorize clearly. So what I'm going to do now is complete the square. Like I said, I'm making these up myself. So when you do these, you'll hopefully find something that factorizes. Normally anyway. So complete the square. So just as easy as factorizing, maybe even easier. So we're going to have minus 9 plus 1. So we have x minus 3 all squared minus 8. If we pop the 8 on the other side now, the reason we would do that is because there is x on one side, and if you think about what's actually happening, it's taken away 3, then it's being squared, then it's taken away 8, and if we undo that, we find x. So we add 8, we square root, so we're going to have plus or minus square root of 8 is the same as root 4 root 2, which is 2 root 2's. So we have 2 root 2's over here. And so therefore x is equal to 3 plus or minus 2 root 2's. Obviously a bit harder, lots of maths involved. So we've got the whole quadratic solving, completing the square, surds, and adding the hardest type of algebraic fractions combined with solving. It's a bit of a beast, so let's have a look at another one. Right, okay, this one's even harder, believe it or not. Now, you definitely don't want to multiply these together. If you do that, you're going to get x cubed, you're going to get a cubic equation, and if you're watching this doing your GCSE, you have no way of solving cubic equations just yet. So don't do that. You'll want to factorize, and this is a particularly tough one because this is dots in disguise. So I'm just going to write this up here. The first rule with factorising is there a highest common factor? And yes, there is. Now you should be able to see that and realise it's now dots in disguise. Okay, so that is the denominator here. So we've got 1 over 2 lots of x plus 3, x minus 3. I'm just going to rewrite this as well. Okay, so let's just imagine we're trying to work this one out here. So let's go 5 and let's go 15. You wouldn't multiply those together, would you? You would make the lowest common multiple, you'd make them both 15. So is there something I could times this one by to make it look the same? And yes, because I have these, this is the same. I actually only need to multiply this one by this bit here. Same reason here. I just multiplied this one by 3 to make it the same. And quite often, when you have a squared and another x, or even another x squared, you can multiply them by a little bit just to make them the same. You don't want to multiply them together because anything over a squared power, you just don't know how to do at GCSE yet, so you won't ever be expected to do that. Right, so let's multiply this one by 2 lots of x plus 3. So times that by 2, I'm going to have 6 lots of x plus 3. Let's just rewrite it because it's going to be easier. Plus 1 lot of 2 lots of x plus 3, x minus 3. So I often get to this stage and think, oh, have I done this bit right? Well, let's have a look. 6 divided by 2 is 3. Okay, so that bit works. And if I cancel off these, because they're the same top and bottom, yeah, it works. Okay, so this and this is the same. I know I haven't done anything wrong. I don't need to change the right hand side again because I haven't made any increases or decreases to the left hand side. I've just rewritten them in different ways. I've turned subtraction into multiplication and I've formed an equivalent fraction here. It's the same as saying 1/2 is the same as 2/4. So nothing's actually getting bigger or smaller. Okay, so adding, let's add them. So we're going to have 6x plus 18 plus 1. So it's going to be 6x plus 19. Sorry, my software's being really annoying tonight. And that expanded is given to us at the start. So I'm going to pop that in there. And we know this is equal to 1. Okay, so again, just a posh version of stage 1. So we need to get rid of this denominator. So let's multiply by it. To both sides, it's going to disappear on the left, and because it's a 1 there, that makes it nice, doesn't it? You know, if that was a 2, you'd be writing 4x squared minus 36. Just multiply both of these terms by whatever is there. Quadratic again. Let's get everything on one side. So that's going to be minus 37. Okay, so that definitely doesn't factorise, and I don't really want to complete the square. I can't divide everything by 2 easily, so I'm just going to whack that in the quadratic formula. So, like I said to you at the start, most of the time they're going to be able to factorise because they want you to be able to do that skill. If you have a calculator paper, there's nothing stopping you at this stage using the quadratic formula, but I would always show your stages of working. Okay, I'll do that as well. So negative b is 6 plus or minus the square root of b squared, 36, minus 4 lots of 2, lots of minus 37, all over 2a, which is 4. So, and then you have to tidy it up. So 6 plus or minus. Okay, so what we've got there, we've got 8 times 37, plus 36. If you're wondering why I just did that in a really weird order, it's because I know this is going to be a plus because I've got a minus and a minus, and I just like to work out this bit first and then add it to 36. So there's my working stage, so my initial working, tidy up, and then my two answers are, I'm going to write them to 4 sig figs. 6.056 and x is minus 3.055, and they're both to 4 significant figures. Hopefully the questions they give you, you'll be able to factorise, you don't have to go through all of that. It's a lot to take in, all 4 stages. It's time to practice. Good luck.